Welcome to our third in a series of career discovery series, My Career, My Future. And today we are very excited to welcome Mr. Bobby Rokes from TurboCam. And he would like to be called Bobby.
Yeah, Bobby is fine.
Yes. So today this is going to be more of just a conversation. So you can ask questions. It's more casual in that way. We are going to discover everything there is about mechanics and Mr. Rokes' career and what brought him to this point. And we are just so excited that he is joining us today. So I give it over to you.
Well, I've been asked to talk to you guys about how I got started in this. I'm going to start right back at the beginning. I grew up in Maine. My granddad had a dairy farm, which had a blacksmith shop, so I started playing with metal very young. When I was a freshman at Lake Region High School over in Bridgeton, I got the shop class, and there was a young teacher there, Mr. Pomelo. It was really nice. And he let us make something. He gave us a choice, make it out of wood or make it out of metal. So I cast something and turned it out of metal, and he was impressed. And just so happens that one of the local print shops had given a printing press to the graphics art department, but it was broken and not working. So I spent 1 year tearing it apart, making parts, putting it together. And I loved it. So I decided that's what I was going to do. How I got in this, for various reasons, I didn't graduate high school. I had to go in the Army at 16. Did that, got out. The VA put me through an apprenticeship. At that time, it was a 2-year apprenticeship to be a machinist. A lot of you probably don't know what the difference is between a machinist and a tool maker, but we'll get to that in a second. So in the state of Maine, when you did that, you could take a test if you wanted to at the end and go for another 2 years to be a tool and die maker, and I did that. Back then, tool and die makers like me, we designed how parts got made. We designed the molds, the fixtures, and everything else. You also had draftsmen who did the drawings, and you had details who did the tolerancing of parts and stuff, and the engineers just designed the parts. If we fast forward to where computers came into the game, they decided that the engineers could do all that and never transferred knowledge, and that's kind of where we are with the problem that we have in engineering right now. So I worked in a bunch of shops, took a couple years, rode around the country on my bike and worked around different places. So basically, how did I get to where I am now? After that, I was working for Palmer Chenard in Somersworth. We made fabric reinforced diaphragms, so I was designing and everything else. And we got bought by a company called Fashida. And they had a rule that you had to have a degree to design their parts. So they sent me to NHTI, and I have a 2-year degree, associate's degree, not in mechanical engineering, in manufacturing engineering. And there's a slight difference. They're very, very close. It's only a couple classes difference, but basically a mechanical engineer will design the part. Me, a manufacturing engineer, will tell you how to make it and build the fixtures and everything else that do it. I now work for TurboCam. I've been there 12 years. I run the tool room. We have our own school. I train there. I'm on the advisory board for the machining program here. Some of you guys know me. I started out the year every other Friday, but since then work's load has gotten to such where I'm pretty much out straight 7 days a week. So unfortunately I have to apologize for not coming back too many Fridays since probably the first of the year for that.
Bobby, may I ask a question?
Absolutely.
So when you were in high school, what were you thinking you wanted to do after you graduated?
Had no idea. I'll be honest with you. I'm gonna give you the same piece of advice I give my grandkids and everybody else. At your age, eliminate what you don't want to do. Sooner or later, something will float to the top that you do want to do. Okay, but I really didn't. My dad had a truck garage. I was working on trucks and rebuilding motors when I was in middle school. Decided that's not really what I wanted to do. You know, part of the family was farmers, part of them worked in the woods. Looked around and said, yeah, that's not really what I wanted to do either. So I kind of eliminated a bunch of stuff. But when I rebuilt that printing press, that just gave me something that I like creating something. It's a creation. I built that. You know, we can look at these parts up here and just, you know, this is some of the stuff we make at work. This is a nozzle ring for a turbocharger, okay? Hot side of a turbocharger. We make all sorts of things. I built parts that have gone to the space shuttle, parts that went in the Apollo program. When you can sit back and say, you know, that thing's on the moon because I made that part, that's cool, okay? I don't, you know, at least it is to me. Might not be to everybody else, but I enjoy it. I really do. Any other?
For those of us not familiar with the industry, what is a turbocharger?
All right. Does everybody know? No, everybody does not know what a turbocharger. Turbocharger has two sides, hot and cold side. What it does is it puts air, compressed air, into the engine to give it a boost. All right. The way a turbocharger works is it takes the exhaust gases that come up through. So you step on the gas pedal. There's a little ring here. It slides up and down, allows more gas to go through here. Spins the turbo faster. Okay. So on the hot side, you have a titanium impeller because it gets really hot, right? Now, if you look at any of these, they compress fluid. So if you look at this distance right here is longer than this little distance right here, right? So it takes this volume of air and puts it down and comes out this volume. So it's compressing it, okay? Air is considered a fluid, so it's compressing the fluid, all right? What do you think this little blade in the middle is for? Just to take up space. Compresses it a little bit more. That's all it does. Okay? So what the turbocharger does is it's force good air into that cylinder. So it gives you better compression, it gives you more oxygen, hence you get more power. That's what a turbocharger does.
So are turbochargers just used in airplanes?
No, these go on trucks. Your little car that has one, some of you guys, they're into cars. What's the difference between a turbocharger and a supercharger? Supercharger is powered by the engine. Turbocharger is powered by the exhaust. A supercharger gives you a constant power and speed. A turbocharger kicks in. A little bit of a difference. We also make, pretty much we do is 5-axis machining. Does everybody know what the 5 axes are? Okay? It's same as math. All right? You have an X, you have a Y, you have a Z. That's 3, right? The other 3, because you can actually have 6, are rotations about those. So if you make something like this, how do I get a tool to do this? I've got to have all those moving at the same time. It's really kind of a complicated thing. But the one other thing that I like about this trade is you're always learning. When I started, they didn't even have computers. Now everything is computerized. When I started, it was a physical job. It's not anymore. I don't understand why we don't have more ladies in the field, because there's no reason why they can't be. If you can lift 50 pounds and you can do a little math, you're good. Okay? Questions?
If someone has a question, just for the sake of the videotaping, I do have to bring you the microphone so that it can be heard. So are there any questions thus far? Anything about the trade? Yes.
How long does one of those parts take to machine usually?
One of these small ones, okay, this is an aluminum blank. Okay, we make this, we have a TAPS division, it's called TurboCam Automated Production Systems, okay? We make one of these out of one of these in about 8 minutes, okay? Now that's fully automated, it runs 24/7, it's all robots, puts them on and off, the conveyor. Now we also have parts that are 48 inches in diameter. They sink in the desert in Phoenix, outside of Phoenix, Arizona, generates power. It takes us 6 months to make one of those because it's made out of aluminum, the blades are thin, so you have to machine a little bit, send it out and have it heat treated, get it back. What heat treat does is just change the molecular structure of the metal, all right? So it really depends on what you're doing. These are high production parts. We make 1 million of these a year, these and these. Okay, you don't make as many hot side as you do cold side because the hot side tends to last a little bit longer. All right, other questions?
Can you speak about what career opportunities there may be right after high school, even if you don't go on to technical school?
Absolutely, I can. So if you graduate high school, whether you take the machining program or not, you can apply. TurboCam, we have our own training facility and training. As long as you can basically show up and not drool out of the side of your mouth, we'll probably hire you. What we're going to hire you to do is just be an operator, and that's pretty much put these blanks on a conveyor, take the other ones off, take a few simple measurements, and enter the data. After that, we have a whole career path. And what I do there is we've hired a teacher, like Scott Meserve, okay? And he teaches what we consider the low-end class, blueprint reading, basic math, stuff like that. So think of that as your 2-year college or your high school. After you get done with that, and if you do good enough of that, you come see me. And I run pretty much a whole year-long course. It's 2 4-hour sessions a week. And when you get done, you can make anything. We take you from understanding the manual machines, which means there's no computer controlled, to a conversational, which has a computer on it, but you actually have a conversation with it. And people think I'm crazy when I say that, but if I have a print and I have, let's say, like everybody knows what a wheel on a car is, right? The lugs around the outside is considered a bolt circle, okay? So I have to tell everything mathematically where it is to machine it. I can go to the computer and say, I want a bolt circle. It's going to say, okay, what size? I'm going to give it a size. How many holes? Okay, what angle do I start from? Now when you machine, 3 o'clock is 0 and it goes counterclockwise on the angle. And then it does it for you. That's a conversation. To a full-blown CNC where everything's written out in G-code, and we get into what's called macro programming, which is like programming a computer in assembly language. It gets right down to where we can actually write the code for things. And we have to, because we have this machine that's making the part. It might be attached by a robot to a balancer, because think about these. Some of these things spin at over 100 grand, okay, per minute. Yes, they have to be balanced. So it'll go on a balancer. The balancer will say, hey, I'm off balance by 2 grams right here. The robot will put it back in the mill machine. The mill machine will come down, cut a little bit off, put it back in there. That all has to be told. So the career path you have, if you went to work for TurboCam, is not just what I do, okay? It's from an operator to accounting. We have computer scientists or engineers that just program computers. Now, the other thing we have a problem with, we use SolidWorks to do design, okay? We use Mastercam to program. But we have our own programming people to add in for the specialty of doing this, okay? We have 3 full-time engineers that are computer programmers that write code just to help us in Mastercam make our parts. But my suggestion is, when you get out of high school, if you want to do any of these things, if you want to be an engineer, if you want to be a machinist, if you even think you want to get down some hands-on type path, take something at the tech school, all right? Take the advanced manufacturing program or something. The engineers, and we have a lot of engineers at work, really, really smart guys, okay? MIT types and all that stuff. But the problem is they don't have the hands-on. That hands-on puts you so far ahead of anybody else as far as what you can do, because it's like common sense. Everybody says it's not common anymore. It's because nobody let you touch the wood stove when you were a kid and realized that hurt, you know, so you still do it, all right? So you've got a lot of paths you can take, all right? A lot of technical paths. And let's talk about one thing that is kind of the unspoken thing right now. Where else can you go to school for 2 years and get out of school and make 25 bucks an hour with no debt? And just saying, most of our operators make about 20. Most of the guys in my room make about 30. That's roughly the pay scale. We pay our top-end machinists, the guys that do the R&D on some of the big parts, more than we pay our engineers, all right? So there's a lot of opportunity out there.
If someone does not feel that they're super strong in math skills, would that hold them back in this career?
It would not. You don't need, really depends on the path you take. But right now, most things are done with software. What you need more than anything else is to understand the science behind it. I think you need probably a stronger physics background than you do a math background. I mean, if you can do trig, you're good, all right? And that doesn't mean you have to remember all the formulas. One of the things that one of the reasons I like teaching is a lot of old people that help me along the way, all right? And it's my turn to give back, because now I have the white beard and not the red beard like I used to have, all right? We have trig books, okay? So if you can look at a problem, pull out what you need and what you have, and plug it into a formula that's in a book in front of you, and run it through a calculator, you're good. I teach advanced math, and I teach it a lot. Most people that are in my class, probably mid-30s to 50, 55, because they've worked here, worked there. And now they're looking for a career, or they just stumble on us and say, hey, this is pretty good, whatever it happens to be. And they all tell me the same thing in the beginning of class. I'll have a class of 10 or 12, and they'll say, oh, I can't do math. I can't do math. We get done, they're doing compound trig, and they don't even know it because it's all examples. Okay, we don't teach the theory-based that you get here. That's good if you're going to go to school, if you're going to go to college to be engineering. The other thing when you go to college, let's say you decide you want to be an engineer, okay? Understand when you go to pick your college, it's very important to understand what type of engineer you want to be and what college you go to, okay? I'm going to just use two because they're two states next to each other. UNH is what's called a calculus-based engineering program. All math, okay? It's all theory. And that's okay if that's what you want to do. Maine, on the other hand, is a technical, okay? Some people will call them manufacturing engineering techs. So you're going to have to do time in the shop. They are more practical based, okay? And they're not the only two. I mean, you can go to MIT and they have both. So understand when you go to college and you pick a college, find out kind of what you want to do. It's okay to change, but each engineering program is different. It really is.
Has anybody in this room decided upon a career path or a college you might want to go to or a job that you'd like to have after high school? Raise your hand if you have. Yeah? Would you like to share with us what you're thinking of doing?
I was thinking about going to welding school up in Berlin.
Yeah. Yeah, welding's a good trade. It's changed a lot. A lot of welding now is done by robots because the fumes are not real good for you. Welding, you get limited to shipyards, boatyards, and construction a lot, or some fab shops and stuff. Good trade. Anything that works with your hands is a good trade. Yep. And Berlin has a good program.
Anybody else like to share with us? Any questions right now for Bobby? I have a question.
Okay.
So you are talking a lot about how much you love this field.
Absolutely.
And we were talking earlier about the mechanical side of what you do or the industrial side versus the creative side and what fulfills you. Can you talk about that a little bit?
We sure can. So one of the things I do, okay, because I run the tool room, let's say we get in what's called a quote. We don't design this part, but they're going to say, hey, you know, guys, can you make us this? All right? It comes to me, and they're going to come to me, the engineers and whoever, and they're going to say, look, Bobby, we need some sort of production system to make these. We need 10,000 a week. These are the machines we're going to run them on. How do you think we hold this? We got to hold it. That's what I do. I come up with how do we hold it? How do you check it? Okay? Now, I'm assuming it's you. Your dad, Dave Champy?
Me?
Yeah? No, she didn't come. He said he had a daughter that was coming. He works with me. He works in quality. So my get with somebody like him that works in quality. It's okay, what do we need to check on this? So we'll either make gauging. What gauging does is just a quick way to say if it's good or it's bad. All right? But that's what I do. I'll design this in SolidWorks, get it all done, give it to the guys in my shop, and we build it. Then we take it out and we make sure that it works. All right? And when I'm done, at the end of the day, I can say they make it 10,000 of these a week because of the work me and my team did, okay? Understand one thing, and this is a very important thing. No matter what you do in life, and especially in engineering and manufacturing, be thick-skinned and understand you're going to be part of a team. You're going to make mistakes, and that's okay, all right? Because you learn from those mistakes. But part of the team is the thing, okay? Don't take all the credit. Always use the team. You'll get way ahead. You will. And respect the old guys, because they know most. But that's what I do. That's what I enjoy. So someday I might be in on SolidWorks for 3 or 4 days designing this. And that's quite honestly the rut and why I haven't been to class. I've been on SolidWorks so long that it's ridiculous, just designing fixtures and tooling and production systems. When I say a production system, let's say I got to make these, but I've also got to make 10,000 of those, 10,000 of those, 10,000 of those. And I can make these 10,000 in 3 days. That machine's not going to set for the other 2 days, are they? So I make a production system where I can change that from this part to that part in probably under an hour. Because every time my machine is not making a chip, I'm losing money. I tell everybody, we get paid to make chips, or we don't get paid. We don't get paid for the engineering time, we don't get paid for the accounting time, we don't get paid for the IT people. We get paid to sell this part. And we negotiate that cost up front. So if I was going to sell you this part for $12, and it takes me an hour to make it, but then I come up with a way to make it in 40 minutes, that profit's mine, okay? And when you work for somebody else, you got to make them more money than they're paying you, or you're not worth it. You won't be there long. That's just the way of the world. That's what I do. How do I make this thing better? You know, now I might start making this, and I might lose money on it the first 2 or 3 months until I get it up to speed. That's okay. Long run, I'll make money.
So when you say design, are you actually drafting and drawing? Or are you doing it on the computer?
I do the whole thing. I come up with the idea, I solid model it, I make the drawings, we get the drawings approved through the team, and that team will consist of an engineer from the floor that is responsible for this, okay, because he's responsible for all the operations. Usually the manager of whoever cell or department is going to go through, me, sometimes quality, depends on what it is, and we'll sit down and get it approved, and then we get it made. So to me, you know, it's very good to understand at the end of the day that you've created something. This is your idea, or your team's idea. One of the other big things I do at work is fix problems, okay? If there's a problem pretty much anywhere in production, they come down and grab me, and we go figure it out. So if there's anything you want to do, start doing puzzles. I love puzzles, you know? Puzzles are great. You know, you do a Sudoku in a couple of minutes, and it's pretty good too. Yeah, but that's what I'm saying. You exercise that brain, because I guarantee everyone in you has a good one. All right, it's just exercising it. So, questions? I know I just bored the hell out of half of you, didn't I? Yeah, this guy here, he's taking a nap. He's eating his shirt. Don't worry, I pick on everybody. Don't worry about it. That's the way I am. Anything else?
Can you describe a typical day for you at TurboCam?
Yeah. I get to work about 6:30 in the morning. I have 2 types of days. I have teaching days and regular days. So we'll start with the regular day. I get to work at 6:30. If I can get my coffee even 7 and not have somebody in my office, I'm doing good. Usually after that, you know, I have to keep my shop flowing, which I have right now 5 guys working for me full time in my shop. So I have to keep them flowing. But usually what happens is throughout the day I have people filter in with problems, or they filter in with questions about design or part drawings. Part of the other thing that I do is I'm real good at GD&T, geometric tolerancing and dimensioning, okay? What that is like the forms of these. That's how things fit together, how things work together. Sometimes they'll haul me into a meeting and basically we'll redesign a custom part from it. It's called design for manufacturability. We'll look at them and say, look, if you change that radius, I could save you $20 a part. And you're making 100,000 parts, that's a lot of money, or whatever it is. So that's that day. The other day, I work in the shop in the morning, I'm in the classroom in the afternoon. Or we have a shop, it's mostly in the shop. But we have our own, like I say, school, kind of like the shop you have here for advanced manufacturing. Right now, my other days consist of, most of my solid work time is done at home because I don't have enough time to actually get into a design at work. It does take a little bit to wrap your head around it. You'll find it as you work, you have different things. Like, I don't design without my music. I'm sorry, it's just the way I am. So you'll find you have things that work for you.
Who's your favorite band?
Me?
Yeah, who do you listen to?
You never know. It decides my mood. I have people won't come in my office if I got Deep Purple playing. But if I got Crosby, Stills, and Nash playing, they'll come in. It depends on my mood. But I am definitely a classic rock guy. But I listen to pretty much anything. You know, my guys will have stuff out there listening to I don't even understand the words, and that's okay. You know, it's their thing, and that's cool. Yeah. What else would you guys like to know? I know you guys got questions. You just don't want to ask. Either that or you're sleeping.
Oh, hold on.
How much time is spent designing the part versus actually making the part?
Good question. That's maybe something we should talk about a little bit. So when you design something, okay, there's a process that you go through. Okay, it's not like I pick it, oh yeah, I think I'll grab this and I'll grab that. You start out with a concept. And what you do is when I look at this, I look at the drawing and I say, what are the critical features? Okay, that GD&T I was talking about lots of times tells how the design's gone. So I'll come up with a model, all right? We'll have a meeting and I'll put it up on the screen and we'll talk about it, we'll tear it apart, we'll adjust it some. So if it takes me to design a simple fixture, maybe 4 to 8 hours. To design a production system could be 3 weeks. So it really depends on how complicated it is. The thing with this is you're going to design something to make this, you're going to go try it, you're going to adjust it. Almost nothing goes right the first time. The other things that when you get, if you go into engineering to understand and you design something, understand who you're designing it for. My main job at work is to make the operator's job as easy as possible. Okay, I do little things like if you have a fixture that's square corners, I round all the corners. Because if you keep picking that up with your hand, it's gonna hurt. By the end of the day, your hand's gonna hurt, okay? You don't want your operator's hand hurting. He doesn't wanna make parts. He doesn't wanna pick that up. That means you don't get production, okay? It is my job as the designer of tools and things like that to make whoever is gonna use them as easy as possible. So with that said, when I have my meetings about tools, who do you think I invite? The person that's going to use them, okay? Always understand that. When you design something, figure out who you're designing it for and keep them in mind, okay? Because it makes a huge difference. The other thing is, do you know what type of tolerances we hold on this? Does anybody understand how tolerances go? Okay? Profile on this, we probably have about 1,000. Your hair is about 3,000 to 5,000 thick. When I make a tool, if you take your hair, stand it up, let's say it's 3,000 thick, we slice it 3 times, you take one of those slices and you slice it another 10 times, that's about what I hold my tools to. Okay, some even a little tighter than that. We have good equipment to do it and we have good process to do it, but it takes, everything matters. That's the other thing too. No matter what anybody tells you when you get in the real world, everything matters, okay? Just the way it goes. Anything else?
I had one more question.
Oh, sure.
So earlier we were discussing some of the wonderful things that are happening in our region and your industry, particularly in Ossipee that brought you here. Could you talk about that, please?
Yes. Yeah. One of the things that I think is one of the reasons why I think manufacturing gets a bad rap, all right, is people don't understand they're everywhere. Okay? In Ossipee we have Mighty Bite. People go buy Mighty Bite. They know what it is. Does anybody know what they do? No, they're probably one of the best in the world at what they do. Okay, they make little clamping systems for people like me. All right? You have a place up here that makes magnets. There's all sorts of machine shops around. A lot more than you would guess, but don't advertise, you know? Don't barely see a sign out there. You might see a little sign that says, you know, Bob LCC or something like that. And it's a machine shop. There's nothing to tell you because there's no reason to advertise. We don't sell to people off the street, okay? So there's a lot of job opportunities. Right now, we could probably, I think we're down 40 or 50 positions. We just, when I started at TurboCam 12 years ago, some of you guys maybe came down to a, was it a couple, 3 years ago they came down, right, just for you, for a tour. We had the building I'm in. It was built in 3 phases. That's done. We built another building, half the size of the one I'm in, around the corner. We just opened up another building next to that one and we're putting in 4 machines a week. Okay? So there's opportunity everywhere. And that's not counting SIG, all the other places around the big shops. All these big shops that can't get their work done, subcontract out to small shops. So hence you have a lot of small shops in the area that do it. You have a lot of talent in this area. The best thing about the Northeast, quite honestly, is we usually work harder than most people in other parts of the country. And that's why you have a lot of, and we care about what we make. It's why we have a lot of good shops around here, a lot of places to go to. I'll give you a little bit of, if you come to me and you have a tour, I'm going to give you my little if you go apply for a job speech. And you can tell me if I'm off track. You go to apply for a job, understand, you're interviewing them as much as they're interviewing you. So one of the my main goals or things that I look for is I drive around the parking lot and I look at all the vehicles. I don't care if they're new. I don't care what year they are. Do they have good tires? Are they in good shape? Because if they are, that means whoever's in there cares about their employees enough to pay them a livable wage. Okay? Understand everything matters. So look at these little things. Observe. Don't walk through life with blinders on because you'll get whacked. It just happens. Okay? Anything else? Any questions? Anybody else I can pick on? Oh, just understand, if you ever do come to work for me, I have one saying, and all my guys will tell you, you're here for my entertainment value alone, okay? That is one of my rules. That, and I have fun at everything I do. All right? Questions?
Bobby's going to be available for the next 8 minutes to have any questions if you want to talk to him privately. This kind of concludes our actual career lecture today. I want to thank you, Mr.
you're
Bobby
welcome.
Rokes, for joining us today. I want to thank all of you for coming today. We really appreciate it. Thank you so much.
Oh, thank you.
Very much. If we could give him a round of applause and say thank you.